Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Representation of data is the next topic of S1 important notes. For ungrouped data, there are two types of ungrouped data: odd number of observations and even number of observations. For odd number of observations, we use these two formulas for quartiles. For Q1, we use 1 upon 4 n plus 1th observation, and for Q3, we use 3 upon 4 times n plus 1th observation. And we use this same formula for median, for odd and even number of observations, and same formula for mean. And mode is the most repeated observation. The difference is only these two formulae. When observations are odd in number, we use these two formulae for Q1 and Q3. For even number of observations for ungrouped data, see, for mean we use same formula, for median we use same formula as we use for odd number of observations. But for these two, Q1 and Q3, the formulas are different. For Q1, the formula is n upon 4 plus 0.5th observation. For Q3, the formula is 3n upon 4 plus 0.5th observation. For example, if n is 14, then Q1 will be 14 upon 4 plus 0.5th observation according to this formula, which will be 4th observation. And we find median Q1 and Q3 of a set of n arranged data. And this is the formula of interquartile range, Q3 minus Q1. For group data, frequency distribution, group data means frequency distribution. This is the formula of mean, where x means class centers or mid values. And we estimate median from cumulative frequency graph. It is the 50th percent of total frequency corresponding value. 50% of sigma f class observation. Q1, it is the 25% of sigma f estimated from CF graph. Q3, 75% of sigma f observation, and which should be estimated from the graph. Modal class is always found from histogram, and it is the highest frequency density class. The highest bar class is the modal class. Percentile, for example, if we need P80, then we need to find 80% of sigma f and then estimate it from the cumulative frequency graph. Mean and variance or standard deviation, you can say. Mean and standard deviation. By assume mean method. So these are three formulae for mean. This is the basic formula you all know, and this is the assume mean formula. And A means assume mean, same as B means assume mean. Sometimes we use this relation, sometimes we use this relation according to given information. Standard deviation, we have 4 formulae for standard deviation. This will be given in exam, and this will also be given in exam. And you can form these two formulae yourself, and these are very simple. If you will replace this x square by x minus a, then you can easily get this formula. Just replace x square by x minus a whole square here, and this x by x minus a. So if you will replace x square by x minus a square and x by x minus a here and here, you will get this formula. Similarly, to get this formula, replace x by x minus b, x square by x minus b square, and x by x minus b. So these two formulas are very simple to learn and very easy to learn. Sometimes we use this relation, sometimes we use this relation, sometimes we use this relation, and sometimes we use this relation according to given situation. See, I'm using this relation in this example. N is 150, sigma x is given, sigma x square is given. So this, information for this is, all informations are given for this formula. And we need this thing, this one. So we just need to equate these two, like this. Now cancel both these square roots. Now substitute this information here, n is 150, n is 150, this is 150, and we can easily get this thing. See, this is very simple by equating these two, this one. Sometimes we use these two relations. It depends on the given situation. Well, addition of a new observation into previous data. Now this concept is very simple and very important as well. Addition or subtraction, both. I'm doing this for addition, you can also do this for subtraction. What if we have this data for 36? This data is given and this data is for 36 observations. A new observation of value 29, observation means x. So x is 29. Was added to this sample. Now get the answers of these for 37 observations. So when you will add 29 here, you can directly add here. See, we can directly add here because this is x. So this is the total for 37 observations, sigma x. But here we cannot add 29 directly into this number. We need to subtract 45 from 29. Like we need to write 29 minus 45 here, and then we can add this result into this result, and we'll get minus 164. So you cannot directly add 29 here as you did here, because here we had x and here we have x minus 45. So do in this way, 29 minus 45, and then add this into this result. Same is here, 29 minus 45 square, do this first and then add this result into this result to get the total for 37 observations. So this is the way to add or subtract a new observation into previous data. For subtraction, put negative sign here, here and here. This is the practice question of that concept. A sample of 36 data values, this and this. Find the mean and standard deviation. First part is very simple. If you know the formula, you can easily find mean and you can easily find standard deviation. So this is the formula for assume mean. Minus 148 is here, this 45 is here, and you leave your answer as a fraction, it's better. Give your answer up to 3 significant figure here. Now this is very important. One extra data value 29 was added to the sample, to this data. Find the standard deviation of all 37 values. Now be careful while adding 29 into previous data. So this is the observation. When you will add this observation into this data, then you need to first write 29 minus 45. You need to subtract 45 minus from 29 like this, and then add this result into this result. Same is here. First do 29 minus 45 square and then add this result into this result to get this answer. Now after getting these two results, use the correct formula of standard deviation. This is the formula, and that's the final answer. Next topic is combined mean and standard deviation. So this is the formula of combined mean. You can either learn this formula or this formula. Both are simple. This formula is very simple. Sigma x, total of first group, total of second group, and sum of the observations of both the groups. And you know sigma x is n times x bar. So by replacing sigma x by n1 x1 bar, you can learn this formula. So you can either use this or this, it depends. This is the formula for combined standard deviation, and you need to learn this by heart. And these two formulas are also. And this is the combined mean. The result of this is here. And how to find sigma x1 square? We find sigma x1 square with the help of sigma 1. This is the formula of sigma. We can easily make sigma x square subject from this formula like this. First we need to square on both sides to remove this root, and then we need to bring this on left side, and then we need to multiply answer with n. So this is a way to find sigma x1 square. For sigma x2 square, just replace all 1s by 2. And this is sigma square. This is the practice question of combined mean and standard deviation concept. Question number 10 from my practice book. Red Street Garage has 9 used cars for sale. So N1 is 9, or Red Street Garage has 9 cars. Fairville Garage has 15 used cars. The mean age of the cars in Red Street is 3.6, and standard deviation is this. In Fairville, sigma x is this, sigma x square is this. Now, this information is given to find this information, sigma x square, from this formula. Check this. With the help of this formula, we can get sigma x square because we have a standard deviation. And this is here. And make sure you write the complete value. Now combine mean, this is the formula of combine mean, this one and this one, you can use any one. So this is the result of combined mean, exact answer, 3 significant. Make sure you will use this exact answer in later part here. Don't use this answer in later part because this is the estimate. We always use exact value in later part. Now we have sigma x, we have both, we have this, we have this. We can easily substitute everything into this formula and get the standard deviation. So this result is here, this was given, 24 is the total of both the groups, both the cars, and this is the combined mean, the exact answer. And make sure you give your final answer as 3 significant figures. So this is the practice question of this concept. Next question of representation of data, this is of frequency distribution, the group data. First we need mid values. So mid values are here, 10.5, this one 25.5 and so on. These values are here. This is the formula for mean and this is the formula for standard deviation for group data. So fx, this is f and this is x. So fx is here. You just need to take the sum of the product of these numbers, this with this, and divided by 234. So this will give you mean. This is the exact answer. We'll use this answer in later part. Sigma fx square, mean you need to square this number. 40, 10.5 square, 34, 25.5 square, 56 is here, square of this number, divide by 234 and minus this answer, square of this answer will give you standard deviation. And we found frequency density for histogram. I'm not discussing histogram in this chapter. I'm just focusing on the calculations of mean and standard deviation and quartiles. In fact, mean and standard deviation. Now, this is the, in fact, last topic of this important notes of S1, representation of data. Well, to construct frequency distribution from cumulative frequency distribution, we have to follow these rules. And these rules are very important. See, data has 2 types, discrete and continuous. When data is discrete, like countable, then always use class intervals. This is very important. Upper class boundaries will be given in cumulative frequency distribution, and we have to construct frequency distribution. For that, if data is discrete, then we will go for class intervals. If number is exclusive, then this is 89 because this is 90, and the first value of the lower limit is always 0. You have to learn this by heart. If upper class boundaries are exclusive, then first value of the lower limit of first class must be 0. But if upper class boundaries are inclusive, then the lower limit of the first class must be 1. You have to learn these two by heart. So the first thing is, if data is discrete, then always go for class intervals. If upper class boundaries are exclusive, then the first value of the first class, lower limit of the first class must be 0. And if the upper class boundaries are inclusive, then the lower limit of the first class must be 1. So this is for discrete data. For continuous data, always go for class boundaries. See, if upper class boundary is exclusive, then make class boundaries in this way. See, this is exclusive and this is inclusive. That's the rule. If one is exclusive, other will be inclusive. If this is inclusive, this will be exclusive. Since this is exclusive, this is same as here. I copied this thing here and I made this inclusive because of these rules. And the first value is always 0 over here. Whenever you go for class boundaries, whether this is inclusive or exclusive, the first value, the lower limit of the first, or you can say the lower class boundary of first class must be 0. The lower class boundary of first class will always be 0, whether this is inclusive or exclusive. But when this is exclusive, then make class boundary in this way. Just copy this thing here and make this inclusive. Just copy this here and make this exclusive. And the first value is always 0. But here, when this is exclusive, the first value is always 0. And when this is inclusive, the first value is always 1. So when data is discrete, always go for class interval. When data is continuous, always go for class boundaries like this and this. Now example questions. Now this data is discrete, number of pupils discrete, and we have inclusive data. So we will use this format. We must have 1 as the lower limit of first class. So this is here. This 600 is inclusive. This 450 is inclusive. Obviously this number should be 451 because we are making class intervals. This 350 is here, so this must be 351 and so on. And this first value must be 1 according to this rule. When data is inclusive, then the first value of the first class must be 1. Now after constructing this, get the mid values. Mid values are very simple, just take the average of these two. And how to get frequencies? This is very simple. This minus this will give you this frequency 300, and this should be here. 4700 minus 4100, 600 will be here, and so on. Now you can easily calculate mean. So this table is compulsory for the calculations of mean and standard deviation, and make sure you follow this rule here. This is the cumulative frequency diagram curve, and you all know how to draw this. You need to use this table for cumulative frequency. You must label both the axes, here cumulative frequency and here number of pupils. And you can either draw a curve or you can draw frequency polygon, cumulative frequency polygon. You have option. Whenever this is graph, CF graph, then you have option. Either go for curve or polygon. This is cumulative frequency polygon. Now the second part of this question is 80% of the schools have more than n pupils. Now this part is very important. Have more than or at least n pupils. They both mean the same thing. So 80% means, first get the 80%. 80% of 5,000 is 4,000. So this is the last value. So get 4,000. This is 4,000. So this is the answer. Because more than means this part of the curve. Let me do this calculation here. 80% of 5,000 is 4,000. So this 4,000 is here. We need this value of n. Whenever this is at least or more than or greater than, then always take this part of the curve. So that's the value of n. It's 80% of 5,000 is 4,000. So 1,000th observation is 170. This is 170. Now the next part. Find how many schools have between 201 and 250 inclusive pupils. So 250 and 201, this is here. So they are 500. If you want to do this from here, then just subtract these two. 200 and 250. This is here, 500. Now, this is of this type, continuous data. Well, since this data is continuous, time is continuous quantity, so we have to go for class boundaries. This is exclusive. So 13.5 is exclusive and this number is inclusive. We have to use this inequality here because of this data. 12.5 is here and this is inclusive, this is exclusive. You just need to copy this here and make this inclusive. And the first value is always 0. I told you when we have continuous data, then first value is always 0, whether this is inclusive or exclusive. This is here. And now get the mid values for the calculation of mean and variance. We need mean and variance. For histogram, use this data. You can draw histogram. You can draw histogram with the help of this data as well. So get the frequency density. These are the frequency densities, these are the class boundaries. So take these on horizontal axis and these on vertical axis. This is here. Make sure you must label both the axes. Time in seconds. Yeah, it's here. Time in seconds and frequency density. And here 10.0 is this number. This number is 10.0. So 10.0 till 10.5 frequency density is 8. This is here. Then this is the next bar and so on. Well, this is the highest bar. So this is the modal class. Next question, number 8. A hotel has 90 rooms. The table summarizes information about the number of rooms occupied. Number 1, draw a cumulative frequency graph. For that, we first need to construct cumulative frequency distribution. So first get the class interval, class boundaries. These are class boundaries. You need to subtract 0.5 from this and add 0.5 into this. From class intervals, we get class boundaries by subtracting 0.5 into this number and adding 0.5 into this number. So these are the class boundaries. And cumulative frequency, this table is optional. You can do these things here as well. Cumulative frequency, copy the first frequency here, then 10 plus 32 makes 42, 42 plus 62 makes 104, and so on. And for this, cumulative frequency is always 0. Let me write this here. For this, cumulative is always 0. For 0.5, 0. For 20.5, 10. And so on. And make sure you choose the scale in the right way. 0.5 here and 2 centimeter is 20. So if this is 0.5, this should be 20.5. Label horizontal axis and vertical axis. Now the next part of this question is estimate the number of days when over 30 rooms were occupied. Over means more than. So you have to come here, 30 rooms. This is simple, 30 rooms here. This is horizontal axis, so you can get this easily. So this one, so these are the days for which over 30 rooms were occupied. 200 minus 24, I think 176. So whenever they say over or more than or at least, remember 3 things: over, more than, at least. Then always take this part of the curve. Over 30 means this part of the curve. So take difference of these two numbers. So 200 minus 24 makes 176. This is here. Now on 75% of the days at most, this part is very simple. This is the lower part of the curve. At most means lower part of the curve. 75% of the days. So 75% of 200 makes 150. So just check the corresponding value of 150. We need this part of the curve. So this is the answer. When it says over, always take the upper part of the curve. When it says less than or at most, then always take the lower part of the curve. Over, at least, minimum, more than, they all means upper part of the curve. Next question. Here we need mean and standard deviation. So for that we need class boundaries and mid values. So mid value of this interval is 3, this interval has 8, and so on. So this is the way to calculate mean: sigma fx over sigma f. Standard deviation is also very simple. If you know the formula, you can easily do that. The formula of standard deviation is this: sigma fx square over sigma f minus square of mean, under root. This is here. You just need to square this number. And so on. Give your answer up to 3 significant figures. Now histogram. For that you have to construct this table. So get the class boundaries first and then get the frequency density. Frequency density is frequency upon class width. So class width is 5.5 minus 0.5 is, I guess, 5. So you just need to divide 59 by 5 and so on. Get the class width from class boundaries. The class boundary is 5. Class width is 5. If you are finding class width from here, then make sure both numbers should be inclusive. You must take both numbers inclusive. It's better to find class width from class boundaries instead of class intervals. And this is the histogram. Label both the axes. Here frequency density, and this is the histogram of the data. Stem plot. We use a stem plot to represent all the data. This diagram is suitable to represent all the data, and this is for ungrouped data. Now, how to construct a stem plot? So the question is, we can understand a stem plot through this example. Represent this information on a back-to-back stem plot. So we don't need to mention decimal here, we will mention decimal in the key. And flat screen is here, conventional screen is here, and we just need to observe the lowest and highest values. Lowest value of these two datas is 0.65 and the highest value is, I guess, 1.07. So 6 should be here, 6, 7, 8, 9, 10. And for example, for conventional screen, 0.69, so 9 should be here. 0.65, 5 should be here. 0.85, 5 should be here. First you have to, basically you have to construct a stem plot in pencil. And then you have, first you need to construct it randomly and then you have to arrange it in ascending order. Like this, 0.69, so 9 is here, 6.5, 5 is here, 8.5, 5 is here, 7.7, 7 is here. First draw this and then arrange these numbers in ascending order, same as here. And check the totals. The totals should be same, 9 observations. And make sure you must mention the key. This is compulsory. So you can mention key in this way. Copy this here, or maybe you can copy this here. 8, 5, this one. 5, 8, 6. You can copy anything. So I copied this here. And I explained this thing like 76 means 0.76 meter of flat screen, and this means 0.7 meter of conventional TVs. Median, since data is odd, well, median, it doesn't matter whether the data is even or odd. For median, for formula of median is n plus 1 upon 2th observation for both types of data, even and odd. So 9 plus 1 is 10, 10 upon 2 is 5th observation is median. So median for conventional screen, 1, 2, 3, 4, 5, this is the median, 74. You need to write 0.74. For Q1, use this formula, 1 upon 4 n plus 1th observation, because data is odd. So it's 2.5th observation. 2.5 means average of second and third, so average of these two. For Q3, use this formula, 3 upon 4 n plus 1th observation, which is 7.5. 7.5 means 7th and 8th. 1, 2, 3, 4, 5, 6, 7 and 8. So average of these two, 0.77 plus 0.85 upon 2. And IQR is very simple, it's Q3 minus Q1. Now find the mean and standard deviation of flat screen. For this, we have to use this formula for mean and this formula for standard deviation. We have done this earlier in this lecture. Next question. The marks of pupils in a physics examination are summarized as follows. Draw a box plot. 2 box plots for history and physics. For history, we have to arrange data in ascending order. This is the ascending order of this data. This is 13 observation, I guess. These are 13 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So data is odd. So for median, n plus 1 upon 2th, that means 7th observation. So 1, 2, 3, 4, 5, 6, 7. This is median. For Q1, you have to use this formula, 1 upon 4 n plus 1th observation. According to this formula, we have got 3.5th observation, which is average of third and fourth average, so 33. Q3 is 10.5th, so this is 7th, 8, 9, 10, 11, average of these two. Minimum observation is 27, maximum is 57. Now we need to draw box plots for both the datas. Make sure you must label the x's. Marks, you can start with this 10. Lowest mark is 27 for this and 17 for this. So this is for physics and this is for history. The width of the box should be at least 2 centimeter. And make sure these whiskers must not enter inside the box. This is the whisker. One difference. The question is state one difference which can be seen from the diagram. So we have to observe the range. More spread in physics marks than in history marks because of the greater range of physics marks than history marks, or greater IQR you can say of physics. So physics marks are more spread out than history marks. You can either compare, you can say large range or larger IQR, because IQR is available, so you can mention the IQR as well. Otherwise range is enough. While comparing box plots, you can just compare box plots through their ranges. Physics marks are more spread out than history marks because this has larger range and this has a smaller range. I hope these lectures, important notes of S1, will help you to summarize the syllabus of S1, and I hope these lectures will help you to perform well in your CIs. Good luck to everyone, and Allah Hafiz. I'm sorry, I forgot to say an important advice: be of benefit to others. Good luck and Allah Hafiz.